So I was up way too late the other night playing Civilization, specifically Civ V.
No, that's dangerous.
It is. And somewhere around turn 300, I just stopped. I wasn't looking at my strategy anymore. I was just staring at the grid
The
itself.
hex grid.
Exactly. I remember the developers made a huge deal about switching from squares to hexagons. And then I look over at my shelf, I see Settlers of Catan, and it hits me. It's the exact same geometry. That's not just like an aesthetic choice, is it?
No, not at all. You went from the just one more turn syndrome
Yeah.
to stumbling on a pretty fundamental truth of efficiency. I mean, once you start noticing that six-sided shape, you see it everywhere. Beehives, of course, but also insect eyes, snowflakes.
Even the North Pole of Saturn, I read.
Even there, it seems like nature and game designers, they're both landing on the same perfect solution.
So we should probably unpack that. Why this specific shape, what the internet calls the bestagon, is the inevitable winner.
Well, it really all comes down to the tiling problem. If you want to cover a flat plane, a 2D surface, without any gaps.
Like a floor or a game board.
Exactly. You only have three options for regular shapes: equilateral triangles, squares, or regular hexagons. That's it.
Pentagons leave gaps, octagons overlap.
Right, so the hexagon is already in this very exclusive club.
But squares tile perfectly fine. They seem way simpler. So why does the hexagon almost always win out?
It wins on pure efficiency. There's this idea called the Honeycomb Theorem.
Okay.
It states that if you want to divide a surface into regions of equal area, but use the least amount of, say, wall or perimeter, the hexagon is mathematically the best shape to do it.
So most space for the least amount of stuff to build it.
Precisely. Which brings us back to the bees.
Right. The wax, it's expensive for them to make, energetically speaking. So a hex grid means minimum construction cost for maximum honey storage.
It's nature solving a resource management problem. And it applies to packing, too. The packing density of circles in a hex grid is about 0.907.
So over 90%.
Over 90%. It is the densest possible way to arrange circles in 2 dimensions. Just pure structural optimization.
Speaking of optimization, that's a perfect segue for what we do in our own work.
It is. This deep dive is sponsored by Silk. If you're trying to find the optimal structure for your business AI training, automation, software integration, you're trying to eliminate the gaps in your workflow.
Right. Silk helps you figure out where AI agents can have the most impact, streamlining your operations just like that hexagonal grid. You should check them out at embersilk.com for your AI needs.
Now, you mentioned nature's engineering. This goes so far beyond just storage.
Oh, yeah. Graphene. It's just carbon, right. But because the atoms lock into that hexagonal lattice, its tensile strength makes steel look like, I don't know, paper.
Exactly. But it's not just at the atomic scale. Think about the Giant's Causeway in Northern Ireland.
Those massive basalt columns, they look like they were carved.
But they weren't. It's from cooling lava. As this thick layer of basalt cools, it contracts.
And it cracks.
It cracks. Nature wants to relieve that tension using the least amount of energy possible. And the most efficient way to do that is for cracks to form at 120-degree angles.
Which is the internal angle of a hexagon. So the cracks just meet up and form these perfect six-sided pillars.
It's the path of least resistance, literally.
Yeah.
And then you scale that all the way up to Saturn, and you have fluid dynamics creating a storm wider than our entire planet in that same shape.
It's just wild. Okay, so let's bring it back to gaming. I mentioned Civ, switching to hexes. Some people still argue for squares, right? For mapping buildings or dungeons.
Squares are definitely better for architecture,
Hmm.
but for movement, they're terrible. It's the whole taxi cab geometry problem.
Moving diagonally on a square grid is longer. It's the square root of 2. It feels like a cheat.
Yeah, so developers have to create these awkward rules like diagonal moves cost 1.5 points or something.
But on a hexagrid.
On a hex grid, the distance from the center of one tile to the center of any adjacent tile is exactly the same.
So you get this consistent radius of movement. It feels more natural for flanking or, expanding your borders. It's not so rigid.
It makes the simulation feel organic instead of robotic.
It really is the Goldilocks of geometry then.
It is. And here's something to leave you with. We've talked a lot about how hexagons rule the 2D plane, but one of the sources mentions a 4D figure. It's called the 24 cell.
A four-dimensional shape.
A four-dimensional shape that can tile four-dimensional Euclidean space perfectly. just like the hexagon does for 2D.
So, if the hexagon is the master key for our surfaces, you're saying there's a geometric equivalent for dimensions we can't even see.
It suggests the universe is built on these incredibly elegant, efficient structures, all the way down and all the way up.
That is a very hopeful thought. We're in a universe that defaults to order and efficiency. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.